everyone, this is a follow-up to my last video where we solved a compound inequality using the word or. This time we're going to solve a compound inequality using the word and. Now there's a little preliminary work here because mathematicians are lazy. Because you see 2x minus 5 in both of these inequalities, mathematicians like to use shorthand notation, so we have to do a little bit less work. So we're saying that 2x minus 5 is greater than or equal to negative 2, and 2x minus 5 is less than or equal to 5. What we can do is write this as a three-sided inequality, which is not exactly proper. Equations and inequalities only have two sides. So when I write this down, you have to interpret this as two separate inequalities that we're just being lazy and writing as one giant three-sided inequality. So this says negative 2 is less than or equal to 2x minus 5, which we had in the above line. And it says 2x minus 5 is less than or equal to 5, which we have in the above line. So this is just shorthand notation. We probably shouldn't use it in math class, but it's so common that we do. Now the good thing about this shorthand notation is it works exactly like solving equations and inequalities. You just have to do the same operation, this time on all three sides. So what I'd like to do is add 5 to all three sides. Negative 2 plus 5 is 3. And then 5 plus 5 is 10. Now we're going to divide by 2 on all three sides. So 1.5 is less than or equal to x is less than or equal to 5. And once again, you need to interpret this as two inequalities, but combined with the word and. So we have 1.5 is less than or equal to x, and we also have x is less than or equal to 5. Now let's consider the graph of the solution of the compound inequality on a number line. I'll do this over here to the right. Once again, I'm just going to put a little dash at 0, a dash at 1.5, and a dash at 5. So, in blue, I'm going to graph 1.5 is less than or equal to x. Or rather, x is greater than or equal to 1.5. So I put a solid dot at 1.5, and I draw an arrow all the way to the right. In red, no, we'll use purple. In red, I'll graph the solution to x is less than or equal to 5. So I put a solid dot at 5, and I draw an arrow going to the left. And now we have to think about the word and as it's used in English. We want to think about all of the numbers that satisfy the blue inequality and also satisfy the purple inequality. So let's think about these in red. Do I want, for example, the number 0 as part of my solution set? No, I don't. The number 0 does satisfy the purple inequality, as you see, but it doesn't satisfy the blue inequality. So the number 0 is not part of our solution. The only numbers that will be part of our solution are the numbers that satisfy both inequalities at the same time, because that's what the word and means. So what I'm going to do to graph the solution set to the compound inequality is I'm going to look at where the two solution sets of our individual inequalities overlap. So my solution set starts at 1.5 and ends at 5. Now, we already knew that if you look carefully at this last line over here. Algebraically, this reads, we start at 1.5, we have all of the x's up to 5, which is exactly what you see graphically. So this is one way to solve a compound inequality that uses the word and we'll practice some more.